Now let's atmospheric pressure is determined from the mean sea level. As the height increases, pressure will decrease. So that is at the mountain top we have low pressure, and in the plain areas we have high pressure. When there is low pressure in an area, now let us understand why there is, how this low pressure and the high pressure will create it. So when sun is overhead, insulations will directly fall mostly on the equator. Generally sun is overhead on the equator. So but it will create rising of air, air have the rising tendency, so it will convert into thin air. When it is will converted into the thin air, so that means this have the less load, so it will create low pressure area. And if the air has the shrinking tendency, if the air has the shrinking tendency, so it will be denser air and thicker also. So there will be high load, then it will create high pressure. So low pressure and high pressure are associated with vertical movement of air. Done. So now we will see dry air is heavier. How dry air is heavy here, and the moist air is thin air. How it will? In case of the dry air, it will consist of molecules of nitrogen, oxygen, and the molecular weight of the oxygen is 16 and the molecular weight of nitrogen is 14. In the most air, that is the water vapor consisting, that is H2O. So now the molecular weight of the H2O is, that is 2 times of the hydrogen, that is having the molecular mass 1, plus oxygen have the 16 molecular mass, that is 18. So the molecular weight of the water vapor is 18 gram per mole. And in case of the dry air, nitrogen, oxygen, they are consisted of, that is the molecular weight is having the 2 atoms of the oxygen, then oxygen have 2 of the oxides, that is 36 gram per mole, 32, and nitrogen 48 into 2, that is 28 gram per mole. So the molecular weight of the dry air is high than the molecular weight of the moist air. So dry air is the heavier air and the moist air is the thinner air, lighter air. pressure gradient force. So what is pressure gradient? Pressure gradient is nothing but the difference of pressure with respect to distance. So the more pressure gradient will lies through more flow of the fast, and because more pressure, then the force on the wind is more. So let if we have the, we know that the wind move from the high pressure to the low pressure, high pressure to low pressure. Now we have two cases. One wind is moving from high pressure, that is 100 millibar to 50 millibar, and in second case we have the wind is moving from 100 millibar to 20 millibar. Wind will move from high pressure to low pressure, that is just to this direction, movement of the wind. Now in the first case, difference in pressure is 50 millibar, and in second case we have the difference in pressure is 80 millibar. So in this case, what is pressure gradient? That is change in the pressure upon the distance. If we consider the distance is same, that is the distance is constant, then the pressure gradient of, this is A and this is B, pressure gradient of A will be equal to 50, and the pressure gradient on B is 80, that is the difference is 80. So the pressure gradient is equal to 80. So we have pressure gradient at A is less than the pressure gradient at B. So now, so the pressure gradient force at A will also be less than the pressure gradient force at B. So what is the pressure gradient force? That is the force due to pressure gradient. If the pressure gradient is more, then the pressure gradient force will be more. So we have concluded that pressure gradient force is directly proportional to the wind speed. Since here force is more, we have more force, so wind will flow fast, that is speed is more, and in this case we have wind blow slow. So pressure gradient force is directly proportional to the speed of the wind. Similarly, if we have two isobars, one isobars are closely packed and second isobars are having much more spaces between them. So here distance is less, and in this case we have distance is more as compared to A, and what speed is inversely proportional to the distance. If the distance is more, wind speed, the distance is less. In case of A, we have the distance is less. In this case, distance is less. So what this will imply? Speed of the wind is more, and in this case we have distance is more. this will imply speed of the wind will be less as compared to this. So as the distance between the isobars is less, then the speed of the wind will be more. The friction is, what is friction? Friction is the resistance to the movement. How at which speed it can resist it. So when there is no friction, that is no hurdle or trouble, अगर वहाँ पे फ्रिक्शन ही नहीं होगा, किसी भी चीज़ को रोकने की क्षमता ही नहीं है, देन द विंड स्पीड विल बी मैक्सिमम. If we took the example, in case of the sea, or the ocean's surface, wind speed will be maximum. Because there is no friction of the surface, having the plane surfaces, nothing to stop the incoming winds. So in case of the southern hemisphere, at the 40° south, 50° south, 60° south, there we have uninterrupted flow of wind. What is the corrosive force? Deflect the direction of wind. How it will deflect the direction of wind? If an object is moving freely in the earth's surface, appear to be deflected in the right it will deflect right in the northern hemisphere, and it will deflect left in the southern hemisphere. It is because of the rotation of the earth on its axis. So how these forces will affect? Now if we look upon how these corrosive forces will affecting. Corrosive force is equal to 2 times of velocity and sin theta. Theta is the angle. So we know that sin 0° is equal to 0 and sin 90° is equal to 1, that is maximum. So in case of equator, 0 corrosive force, and in case of poles we have maximum corrosive force. Now the question is how the direction of these wind will get reflected in the right side in the northern hemisphere and in the left side in the southern hemisphere. So to understand this, let's have an example. Here we have equator, here we have 30°, 60°, 90°, 30°, 60°, 90°. Place A, place B, place C, place D. 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 Place A, B, C, and D. D. These are the 4 different places on the earth having the different latitudes and longitudes. Now suppose the earth rotates from west to east direction. Rotation of earth is from west to east direction. Speed is inversely proportional to distance. Earth completes its one rotation in 24 hours. So the distance at poles is minimum and the distance at the equator is maximum. So the distance traveled by the winds at equator in 24 hours is much more than the distance traveled by the earth at the 90 degrees. So what it means, that is the at the poles it is mostly static, not so much movement, and in case of the equator that it will travel more distance in 24 hours. So the speed will be maximum at the equator and speed of the earth will be minimum at the poles, because in the 24 hours it will complete its rotation around the equator, and in case of the poles it will take 24 hours to complete the rotation around to complete the one rotational distance at the 90 degrees. So here distance at the poles we have the minimum speed. Suppose the speed we have is at the equator maximum speed, let's take 100 km per hour, let's take. So as compared to the equator at the 30 degree the speed will be less. Suppose it is 50 km per hour. Now at the 60 degree latitudes the speed will further reduces. It is 20 km per hour. And at the pole the speed is minimum. Let's check, is it 2 km per hour. Now rotation of earth is in this direction. From west to east. Suppose a person is standing on the 30 degree latitudes. A person is standing here and a person is standing here, and he moves towards the equator. This person have to move towards the equator. At the 0 degree. From B place he is moving towards the equator at the 30 degrees north and the 30 degrees south. When he moves from the 30 degree north towards the equator, wind will move from west to east direction. So when he will reaches from here to this point B at the equator, the speed of the earth is maximum at the equator. So instead of reaching on the B surface at the 0 degree, it will when it will reach towards this, the earth will rotate and this surface will be occupied by A. B will be here, eventually C is here and D will here. So what we have concluded, instead of reaching upon the B position, he will reach on point A, because A will occupied here as the wind speed of is here maximum. When the same person at the 30 degrees south, when he will move towards the equator at the 0 degree on the same position B, speed at the equator is maximum. So when he will reach upon the B point at the equator, the earth will rotate from west to east. So the point, instead of reaching on the point A, he will reach upon the point, instead of reaching on the point B, he will reach upon the point A, because as the earth will rotate, the A point occupy this surface and B will occupy here and the C will be here and eventually D will be here. So instead of reaching upon the B, he will reach on the A. So here he will reach on the point A. So till here we have concluded that when the from in the southern hemisphere, the direction will be deflected toward the left side, and in case of the northern hemisphere, the deflection is towards the, from this person's perspective, is the right side. Here we have deflection at right, and in this we have the deflection having left direction. Now the same person have to reach, now the this same person B will reach toward the 60 degrees south. When he tries to reach on the 60 degrees south, he have to reach on the point B, but the earth will rotate. So when he speed is reducing, so instead of reaching upon the B place, he will reach on the, this place will occupy here, earth will get revolved, earth will rotate on its axis. So instead of reaching upon B, that area will be occupied the D place. A will be here, B will be here and C will be here. So what will he will reach upon the D point. This is the direction. So from this person's perspective, at which direction the deflection is? Left side. Similarly, when the person, now the person is at D point. Suppose now if he has to come, so he will come on that position, he will tries to come on this position on the D surface at the 90 degrees. Here the speed is much more low. Now let's suppose, now the person having on this position have to move he wants to move on same position, that is from poles. Now he is walking towards the 60 degrees south latitude. At the poles the speed is minimal, and at the 60 degrees the speed is much more than the poles. So when he will reach upon the D point, instead of reaching on the D point, he will reach on the A point. He will reach here, because the earth is getting because of the rotation of the earth, the position will vary. So when he will reach upon the D point, that place will be occupied by the A surface, and on the A surface there is the B place, and on the B place there is the C place, and D place will come in place of the C. So the person, instead of reaching on the D point, he will reach upon the A point. That is deflection towards the left side. Now, in case of the northern hemisphere, we have seen that between the equators and the 30° north, the deflection is toward the right side. Now, if the same person on the point B, he tries to go on the 60° northern latitudes, he wants to be there. Hai? Now, when he will reach upon the point B, because of the rotation of the earth, places will get replaced. So instead of reaching upon the point B, he will reach upon the point D. He will reach here. That is, when he will reach upon the B point, when he will try is about to reach on the B point, this place is occupied the D surface. That is, here we have the D surface, here the A, here is the B, and here is the C. So eventually he has to be on the B point, but instead of reaching, when he will reach upon the B point, he will reach on the D point. Now the same person, if he is on the poles, he will try to come on the D surface. He wants to come on that point, and at the poles the speed is much low as compared to the 60° north. So when he will reach upon the D point, the earth will rotate and this surface will be occupied by the A. Here we have D, here we have C, and here we have B. So instead of reaching upon the D point, he will reach on the A point. So in the between the 30° north and the 30° south, deflection is towards right side. And when he will move from poles to towards the equator at the 60° north, the deflection is towards the right side. So what we have concluded here, that in the northern hemisphere deflection is toward the right side, and in the southern hemisphere deflection is toward the left side. This is the Coriolis force. Instead of reaching on the same position, there is a deflection in the place. So similarly with the happens with the winds. So instead of reaching the winds from the B to the B surface, he will reach towards the equator, he will reach upon the A point, and towards the pole he will reach upon the D surface. So this is the deflection in the wind's direction. Suppose there, this is a low pressure area. So low pressure area, and we have high pressure area. In the high pressure area, there is the surplus of wind, so it will and in case of low pressure, these are the descending airs. So in case of the northern hemisphere, deflection is towards right. So when these winds are moving in this direction, so right side will be in this direction, they will move. So instead of moving in this direction, this wind will get reflected in the right side of the direction. It will also get deflected, it will also get deflected, it will also get deflected, it will also get deflected. In case of the high pressure areas, wind will deflect toward in the northern hemisphere, it will deflect toward the right side. So when these movements are there, so it will reflect in this direction, it will move this direction, this, this and this. So this is the in case of the high pressure area and in case of the low pressure areas. Sorry, गलत हो गया ये. सही था. हाँ, इनके if we have the high pressure areas, that is the rising air. So now instead of moving, it will deflect in the right side. And in case of the southern hemisphere, southern hemisphere deflection is toward the left side. If this is the low pressure area and this is the high pressure area, in the low pressure area wind will be sinking air, that is entering air, and in case of high pressure area wind will exit. High pressure to low pressure movement. Now deflection is toward the left side. So when these winds are moving from the high pressure to low pressure area, it will deflect in the left side. This will deflect in his left side. This will deflect in his left side, and this is in left side. In case of the low pressure areas, so it will deflect towards this side. This will toward this side, and this side. So here what we have concluded. So in the case of the southern hemisphere, formation of the cyclones, how they will form. In the low pressure areas, and this is the high pressure areas. The low pressure, these are the cyclones, and they are the anticyclones. Similarly, in the northern hemisphere, high pressure will create the anticyclone and the low pressure will create the cyclones. Around a high, it is known as the anticyclonic. So when along with the high pressure areas, these are known as the anticyclonic circulation. The direction. Till here what we have studied, frictional force is inversely proportional to the speed of wind. Second is pressure gradient force is directly proportional to speed of wind. And the third is coriolis force, which will determine the direction of wind. So if there is a less dense, now suppose when the heat is more, so air will expand. As the air will expand, so it will become less dense, and when will be less dense, so it will create rising of air. When the air rise, it will create low pressure, and if we have the cold areas or cold temperatures, so air will contract, that is contraction in air, density will increase. When the density will increase, air will shrink. It will create high pressure. So these are the creation of the high pressure of area and the low pressure areas. If we have the low pressure area, now suppose this is our earth surface having low pressure areas. Air will rise up. This is our troposphere. So at which area this air will occupy? This is the zone of accumulation. And this will be zone of deficit. That is nothing but the low pressure area. Now the zone deficit zone will be filled by the other side. And if we have surface, so the low pressure area, the wind surrounding will be occupy this deficit area. So low pressure area will be zone of convergence. And if this is the surface and the winds are sinking, that it will create high pressure area. When it will create the high pressure area, so wind will start diverging. It will start diverging. This is the surplus area. It will start diverging. So now this area is known as the zone of divergence. So if there is a low pressure area and there is a high pressure area, wind will move from high pressure to low pressure. This is the direction of movement of the wind. This is the deficit area, will be occupied by the surrounding air, and this is the surplus. So when these wind will start rising, they will rise, and as they rise they will get cold, and as compared to this area there will be created a high pressure area, because there was existing air and this rising will also getting merged with this air, so it will create here the surplus and it will also become the cold, so it will start diverging from their sides. Now the area is the having the high pressure area. This means the air is sinking here. If the above air is sinking here, so there must be created a deficit. There must be deficit area, that is low pressure area, and this low pressure area is getting filled by the surrounding high pressure areas. So this is the circulation of the wind. So the horizontal movement, that is from high pressure to low pressure, is known as the advection. Now we have studied at the equator we have the low pressure, 30 degrees we have the high pressure, 60 degrees we have the low pressure, and the polars we have high pressure. So in the northern hemisphere, winds will get deflect. This is the movement of the wind, high pressure to low pressure areas, high pressure to low pressure. This is the movement of the wind. So instead of movement of the wind at the 30 degrees to the equator, when it will move from high pressure to low pressure areas, it will reflect in his right side. That is the deflection. So the wind will coming from the high pressure to the low pressure towards the equator will deflect in the right side. Now the wind will flow from the 30 degree to the 60 degree. 30 degree having the high pressure and the low pressure at the 60 degrees. So wind will move from the high pressure to low pressure, that is in this direction. So instead of moving in this direction, they will get in the reflected in the northern hemisphere. Northern hemisphere deflection is toward left, so right. And in southern hemisphere deflection is toward left. So instead of moving in this straight direction, it will deflect in the right side. Similarly this, they will deflect in the right side. Now at the poles, wind will blow from the poles towards the equator, having the higher pressure at the poles and at the 60 degrees low pressure. So instead of moving, these winds have to move in the straight direction, so they will get reflected in the right side of their direction. So they will deflect in their right side. In case of the southern hemisphere, wind will movement will be from high pressure to low pressure always. So instead of moving direct, they will deflect in the left side because of the rotation of the earth, that is they will move in the left side. So instead of moving direct straight, they will move in the left side. Similarly at 60 degrees at the 60 degrees south we have the low pressure, and at the 30 degree high we have the high pressures. So wind will move from the high pressure to low pressure. So they will be get reflected towards the left side. And at the polar high pressures, instead of reaching direct state, they will deflect in their, this is the movement, and instead of this they will get deflected in their left side, that is in this direction. Now this is the moment, that is low pressure, high pressure, low pressure, high pressure. So wind will move from high pressure to low pressure, high pressure to low pressure. As compared to the low pressure, here we will have the high pressure, here we will have low pressure, high pressure, low pressure. We have done. Now as we know that the troposphere have the maximum height at the equator, that is 18 kilometer, and at the pole the height of the troposphere is 8 kilometer. So this is the variation, that these the cells will still formed have the higher at the equator and will have the low distance at the poles because of the variation in the troposphere length. So when in the high pressure, here we have the high pressure, it will, since this is cold now, So it will form clouds. Clouds will form here. Still they are having the cold, and at the troposphere, and after that the troposphere will the layer after that there is a tropospheric layer, and they will rise more since they have cooled down, so they will start deflecting. That is, now it will become cold and dry air, having the densities more. Now the concept of the Hadley cell and the Ferrel cell. At the equator, low pressure air will rise, creating a high pressure as compared to the equator. This is the formation of, we have already done. That is this. They will start forming this. Let's make. This is equator. 30°, 60° poles. 30, 60 poles. Here we have low pressure, high pressure, compared low pressure, high pressure. Wind will move from high pressure to low pressure. This is the direction of the wind. High pressure to low pressure. It will rise. At the low pressure, it will rise. As compared, there is the high pressure, there is low pressure. Low pressure, it will stay rise. Then it will sink, creating high pressure. It will start low pressure, it will rise in this and in this. This is the formation of the cells. That is like this. At the poles, high pressure, 60° low pressure, 30° high pressure, equator low pressure. So these will form the in the form of the circulations. So at the equator to the 30°, this is known as the Hadley cell, and between the 30° to the 60°, it is known as the Ferrel cell, and at the 60° to the poles, it is known as the polar cells. Now at the 60°, at the equator, the air is sinking. There will form clouds. Rainfall होगी, so it will create tropical. So at the equator we have tropical rainforest. At the 30°, it is the sinking air. desert will be there.